Hi everyone, today I want to continue chapter 13 and I would like to focus on transfer functions. Now, the question is that why we need to learn about transfer function and what is the difference between solving for a transfer function and solving a particular parameter in a circuit. Let me show you a circuit and see what are different parameters that can change your response and affect your response, and then what we are looking when we are talking about transfer function. Let's assume that we have a circuit like this, and in this circuit we are looking for VO. Now I want to know what are different parameters that affect the response of the circuit, which is VO of t. So let's write the different parameters. The first one is how your circuit is connected. So how your inductors and capacitors are connected. So the first parameter is circuit configuration. The second parameter that you need to focus on is your input type. For example, your input can be in a step, it can be an impulse function, or it might be a sinusoidal, it might be a ramp function. You can have a bunch of different input and you can select between them. So depends on which input is being applied to the circuit, your response is going to be totally different. So if the input is just in a step function, then what you expect to see as VO is going to be a constant value because your circuit is going to be stable at the end, and your VO is just, for example, a number. It's 10 volt, it's 2 volt, whatever. It's going to be a fixed number. If you apply a sinusoidal, you're going to have a completely different response, and what you're going to see at your parameter of interest, which is VO, is going to be sinusoidal as well. So the second parameter that affects your response, which is VO, is your input type. And the last one is your initial values. And you know why they affect your circuit. Because, for example, if you have an inductor and it has some initial value, you have to show that in your Laplace circuit by a current source or a voltage source. Same for your capacitor. The initial values of your inductor and capacitor will be modeled by an extra element in your circuit. So obviously, if you have some initial values, they will change the equation and you're going to have a different response compared to the situation that you don't have any initial values. So here you can see that the response of the circuit depends on these three main parameters. Now, when you're solving for your response, you're focusing on VO and you want to consider all those parameter. You are considering what is your circuit configuration. You know about your input. You know what is your input exactly, and you describe the input in Laplace domain, and you know your initial value. So you include components such as voltage source or current source in order to describe the initial values of your element. However, sometimes our focus is only on circuit configuration. So we want to know what is the effect of source configuration on our output response, no matter what is input and initial. So what we are going to do is that we are assuming that we don't have any initial values. So the initial values are equal to 0. So if we consider initial value to be equal to 0, then whatever we have as our response does not have anything to do with the initial value. So we cannot see the effect of our initial value in our response. And also, in order to make sure that we are not looking at the effect of input as well, we will consider the input in its general form. So here, instead of describing my input with its exact function, I'm going to just describe it as VG of S. So I just know that I have this particular input and I don't know about what I don't want to be I don't want to specify what is the exact input type and parameters of the input. So I'm going to go general regarding the input type. In this scenario, if I consider the initial value to be 0, the input type to be in general form like as VG, then I can focus on my circuit configuration and I can see what is the effect of circuit configuration on my response. That's where we say we are looking at transfer function. So this is a definition of transfer function. So your transfer function can tell you what is your output, which is here it's VO of S, whenever in terms of your input, so as something multiplied by your VG of S. So because you're considering your VG in general form, so this relationship only describe the effect of your circuit configuration. So now let's be more general. In general, if we have a system or circuit and we apply an input like X of S, and let's assume that we're focusing on a particular parameter as our output, and I'm going to call it as Y of S, then H of S, or the transfer function of this system, which describe the relationship between this output to the input, is basically the Laplace transform, the ratio of output Laplace transform to the input Laplace transform. So in order to find the transfer function of a system, what I need to know is the relationship between the output and input Laplace transform. So this is what we are looking for. And don't forget that we are assuming that we don't have any initial values. So all initial values are equal to 0. So whenever I'm talking about transfer function, I'm assuming that initial values are equal to 0, and I have to use general term for input. I'm not supposed to specify what is my input exactly. So even if I tell you, for example, your input is, so for example, VG is equal to 100 sine of omega t, you have to use VG in your calculation, and you're not allowed to use this 100 sine of omega t, because then you're basically solving for your response and you're not solving for the transfer function. And finally, I want to remind you that we might have more than one input, and also the definition of our output signal of interest can vary. So it means that every single circuit can generate many transfer function. So it doesn't mean the transfer function is not something unique. It depends on which signal you're choosing to be your output and which input source you're selecting as your input for the transfer function.